Hey guys, so in this video I'm going over lesson 3.1, which is factoring GCF, or greatest common factor, and where A equals 1. Do you realize that this is the Math 2 notes, not the Honors Math 2 notes? Honors Math 2 students, the only thing different is a few extra problems, but you will still get the main ones, the more difficult ones. So let's begin. So factoring polynomials with a greatest common factor, or GCF. What is a GCF? GCF of a coefficient is the biggest whole number that is a factor of all coefficients in a given problem. GCF of a variable is the smallest power of the variable from each term. If variable is missing from any terms, it is not a part of the GCF. Key thing in here, smallest power. As long as all terms have the variable, you're looking for the smallest exponent or smallest power, and that's going to be your GCF. Always look for the GCF, or greatest common factor, before using any other method, any other factoring method. So in these first two, we're going to identify the GCF. Now, some of you can go ahead and say, all right, we have 24 and 16. Biggest number that can go into it, or greatest number that can go into it, just like our GCF, greatest common factor, is 8. Now, for the people that can't visualize this, you can do your factor tree kind of like we did for our radicals. So we're going to have our 24. We're going to separate it out to our prime numbers. So smallest number that can go into 24 is 2. I know 2 is prime, so I can circle it. Well, let's not circle it. Let's just stop there. So our other number is 12, because 2 times 12 is 24. 12 is not prime, so we're going to keep on going. 2 times 6. 2 is prime, so we stop. 6 is the other number. And keep going. 2 and 3. Now we have 16. So we're going to separate 16 out. Smallest number is 2, then 8, so 2 times 8. 2 is prime, so we're going to go on 8. Number 8 is 2 and 4. 2 is prime, so we don't have to expand 2, but we do have to expand that 4. So we got 2 and 2. Now, looking at all of these prime numbers, we're going to see what is in common. So starting with our first prime number, which was 2, is there another 2 underneath 16? Yes. So we got a single 2 under both numbers. Is there another 2 under both numbers? Yes. There's one and there's one. Is there yet another one? Is there a third 2 underneath both numbers? Yes. Now looking at the bottom of the roots of the trees, of the prime trees, is there anything else in common? So what's left is this 3 and this 2. There's not another number in common, so we're done. So we have 2, 2, and a 2 in common. We multiply them together and we get 8. Now, everything I just did is just in case you cannot visualize that the greatest common factor is 8 given 24 and 16. Now the variable. Do both terms have x? Have an x? Yes. So that means I'm going to have an x in my GCF. What's the smallest exponent of x? I've got a 2 here and an understood 1 there. So that understood 1 is my smallest exponent. So that's going to be in my GCF. Because it's 1, you do not have to write it. So 8x is your answer. Well, what if you had 30 and 36? There we go. So I'm going to get 30 and separate it out. Again, if you can visualize it, go for it. If you cannot visualize it, do what I'm doing. I'm going to do 3 and 10. 3 is prime, so I don't have to keep going with the 3. 10, I've got 2 and 5. 2 and 5 are prime, so I can stop. 36, I have 6 times 6. Neither are prime, so I'm going to keep going. 2 and 3, 2 and 3. So what is in common? I've got a single 3, single 3. I got a single 2 and a single 2. There is nothing else in common, so that is what I end up with. So I got 2 times 3, which is 6. So number-wise, my GCF is 6. Both terms have an x. So my x is going to find its way in the GCF. My smallest exponent of x is 2. The reason why y is not in the GCF is because 36 times x to the third does not have a y. So if you're going to include a variable in the GCF, it has to be in both terms. Going on. So steps for factoring. Find the GCF of all terms. Divide each term by the GCF. Put GCF in front of terms in parentheses. So for example, number 1, we have 8 times x to the third. We also have negative 8. So hopefully we can see that our GCF would be 8, number-wise. The reason why we do not have negative 8 as our greatest common factor is because both 8s are not negative. A variable, our x variable, is not going to make its way into the GCF because the negative 8 does not have a variable with it. So it's not in common. So it doesn't get included. So we're going to take each term and divide it by our GCF. So 8x to the third divided by 8, well, 8's cancel out. And you're left with x to the third. Negative 8 divided by 8, well, negative divided by a positive is a negative, and 8 divided by 8 is 1. So our answer, GCF, parentheses, x to the third minus 1. And that is how you would do these. So I want to make sure that we hit the main ones just in case you come back and review. Use this as a review. So I want to jump to number 3. And yes, for my honor students, it may be a different number. Just look for the 30y to the 4th, z to the 3rd, x to the 5th as the first term. So number-wise, we have 30, 50, and -10. Hopefully we can see that our GCF, number-wise, is 10. Because I can take the smallest number and divide everything else by it and get whole numbers. So that's why my GCF number-wise is going to be 10. Next, I'm going to determine my variables that make it into my GCF. I see a y, and y. So the y's are in all three terms, so it's going to make it into the GCF. The only exponent for y is 4. So we're going to have y to the 4th. Then I see a z, so I see a z, z, z. So z makes it in all three terms, so it's going to make it into the GCF. The smallest z exponent is 3. And then lastly, x, we've got an x in the first term, x in the third term, but not a x in the second term. So it does not make it into the GCF. So the first part of our factored form is going to be 10y to the 4th times z to the 3rd. We're going to have a parentheses and all of this great stuff that's coming. So now we've got to take each term and divide by the GCF. So our first term was 30y to the 4th, z to the 3rd, x to the 5th, divided by our 10y to the 4th, z to the 3rd. Well, we already kind of reviewed 30 divided by 10 gives you 3. Anything divided by itself is 1, and all of this is multiplication. So y to the 4th divided by y to the 4th cancels out. Z to the 3rd divided by z to the 3rd cancels out. And you're left with x to the 5th. So 3x to the 5th. Then we've got 50, y to the 4th, z to the 5th, over our GCF. So 50 divided by 10 gives us 5. The y's cancel out again because the exponent is the same. It's the same thing divided by itself. And then we have like bases that are dividing. We reviewed a little bit of this last unit. When we're dividing, we're going to subtract the exponents. So you have z to the 5 minus 3, which is the same thing as z squared. So we have a positive 5z squared. And then our last term is -10 y to the 4th, z to the 3rd times x. In our GCF, we're going to divide by it, y 4th, z to the 3rd. -10 divided by 10, negative divided by a positive is a negative. You can put a 1 there if you need to. Y to the 4th divided by y to the 4th cancels out. Z to the 3rd divided by z to the 3rd cancels out. And you're left with x. You do not need this 1. You do, however, still need that negative. Because it's negative x, that's what goes in our answer for our factored form. Going on. So pause the video and attempt number 6. You should have gotten your GCF for x, y squared times z. So your factored form should have been this. If you did not get this, please reach out and I will gladly help you. So, if a does not equal 1, to factor, a trinomial means to write it as the product of two binomials. So check for GCF still. So for number 1, our A is the understood 1, our B is 6, and our C is 8, referring to our y equals ax squared plus bx plus c. So do we have a GCF? Looking at x squared, 6x, and 8. No, we do not have a greatest common factor. All 3 of them do not have a variable, and we cannot divide the numbers by anything other than 1 and get whole numbers. So there is none. So to create this factored form, what we're going to use is the big X method. What we have to do for the big X method is we're going to take our B and put it on the left side, take our C and put it on the right side, and we want 2 numbers that multiply to get C. We also want these magic numbers, or these special numbers, to add to get B. So in this case, our B is 6 and our C is 8. So what times what is 8? You can create a table if you need to, if you can't visualize it. So the first one we can try is 1. So 1 times what is 8? 8. Next smallest number to go into 8 evenly is 2. 2 times what is 8? 4. And then once you get to the next number that can go into 8 evenly, it would be 4, and it continues back up the other side of the table. So then we want to say, okay, if I did 1 plus 8, does that give me 6? No. Even if I come in here and make one of these negative, can I make it equal 6? How about both of them being negative? No, it cannot. We cannot. What about 2 and 4? Can we do 2 plus 4 to give us that B? Yes. So we want, and that works out, we wanted that positive 6. So our magic numbers are going to be 2 and 4. Once you have your magic numbers, you're going to set your factored form up, 2 parentheses, whatever your variable was comes first in the parentheses. And now your magic number, your first magic number was positive 2, so you're going to have plus 2. Second magic number is 4, positive 4, so you're going to have plus 4. And that is how you're going to set up your factored form if A equals 1. So let's do another one. Let's do, again, my honor students, it may be a different number, but it's still the same problem. Let's do this one. do we have a GCF? We're looking at terms x squared, negative 5x, and negative 6. No, we do not have any GCF. So we're going to create our big X method. Our B is going to come over here on the left. Our C is going to go on the right. So we got negative 6 and negative 5. So what times what gives us negative 6, but also adds to give us negative 5? Well, if we start off 1 and 6, well, 1 times 6 is 6, but we got to make one of them negative. So I'm going to set it up like this. First magic number times second magic number equals negative 6. We also want first magic number plus second magic number give us negative 5. So we agree, hopefully 1 and 6 is going to give us those answers. Well, which ones have to be negative? Do the 1s have to be negative, or the 6s have to be negative? So if we did negative 1, we have negative 1 plus 6. That doesn't give us negative 5. It gives us positive 5. What if we had negative 6? 1 minus 6, or 1 plus negative 6, does give us our negative 5. So that means we've got to check our multiplication. Positive times a negative is a negative. So that does give us our answers and what we want. So our factored form, the variable we were given is x. First magic number is positive 1. Second magic number is negative 6. Now, what if there was a GCF? What if we had this problem? Looking at 2x squared, looking at negative 6x, and looking at negative 140. Again, you can use your factor trees to figure out what is in common. Hopefully we can see, though, that it's 2. There's not a variable in each term, so the variable is not part of it. Once we find a GCF, that 2 is going to be on the outside, and we're going to factor out that GCF. So we're going to take 2x squared divided by 2. We get just x squared. Negative 6x divided by our GCF. We get negative 3x. And negative 140 divided by 2 gives us negative 70. Once we do this, you can go ahead and put it in your factor form line. We only care about what's underneath or what's in between the parentheses. So at this point, our A equals 1. We can go straight into our big X method. Our B, then our C. Want two numbers that multiply to give us 70, but also add to give us 3. Add or subtract. So 70, we can create a table. 1 and 70. 2 and 35. 3 can't go into it. 4, no. 5 would be 14. 6 can't go into it, 7 can, 7 and 10, so on and so forth. So we want number times a number to give us negative 70. Those same numbers have to add to give us negative 3. Well, 1 and 70, adding them together or subtracting them or making them negative isn't going to work. 2 and 35, adding them or subtracting them, making one or both of them negative, isn't going to give us 3. 5 and 14, nope. 7 and 10, yes. 7 and 10. Now, do one of them or both of them need to be negative to make these statements true? Yes. To get negative 3 for the addition part, we have to make the 10 negative. Once we make the 10 negative, we get that negative 3. If we make the 10 negative for the addition part, we have to make it negative for the multiplication. Positive times a negative is a negative, and that's what we wanted. Magic numbers are finished. We got our 2 parentheses with our greatest common factor out front. First magic number was positive 7, so we have plus 7. Second magic number is negative 10, so we have negative 10. All right. So I want you to pause the video and see if you can get the correct answer or the correct factored form for number 8. You should have gotten 3 as the greatest common factor, x minus 1 times x minus 6. If you did not get this answer, please reach out to me or ask during the live sessions. Thank you guys.